In the last video, we talked about solving quadratic equations by factoring. Now we're going to solve some by the square root method. The key to this is that when x squared equals some number, then x is either the positive or negative square root of that number. So for example, that equation that we solved before by factoring, x squared minus 49 equals 0, we could also solve by taking square roots. So I could add 49 to both sides. So it says x squared equals 49. And now if we want x squared to equal 49, x would have to be a number that, when you square it, gives you 49. Well, that would happen if x were the square root of 49, which is 7. And it would also happen if x is negative 7, because negative 7 squared also gives you 49. So there are two solutions. Don't forget to give both of them. X equals plus or minus the square root of 49. And of course, the square root of 49 is 7, so x equals plus or minus 7. And this plus or minus symbol really is sort of a shorthand way of saying that x could equal 7, or it could equal negative 7. So there's our two solutions, 7 and negative 7. But the key thing here to keep in mind is when a variable squared equals something, that variable by itself equals plus or minus the positive or the negative square root of that thing. Let's try this one. X squared equals 17. So what's x? It's plus or minus the square root of 17. Simple enough. Just don't forget the plus or minus. So that means you could also say, well, x is either the square root of 17 or negative square root of 17. That means the same thing. And if you pulled out your calculator and asked your calculator what the square root of 17 is, it shows up as 4.1231 and then some more digits after that, as much as the calculator has room to show you. So it's one of those irrational numbers. You can't get what the square root is exactly. So if we want an exact answer, you have to leave it like this. You can't say what the answer is exactly any better or simpler than just plus or minus the square root of 17. But sometimes what we want is a decimal approximation. We want to know that it is a little bit more than 4, that it's about 4.1 or 4.123. So as a decimal approximation, x is approximately plus or minus 4.12. So if I ask you to solve a quadratic equation, you can just leave it like this, unless I specify that I want a decimal approximation. And if I ask for that, then you ask your calculator what this is and give me the decimal version, which in this case would be positive and negative approximately 4.12. Now, in this next example, it's not just x that's being squared. It's an expression that's got a little more than just an x in it, but this works the same way. We got something squared equal to 25, so the something has to be plus or minus the square root of 25. So that means that x plus 8 could equal the positive square root of 25, which is 5, or it could equal negative 5. And then either way, to get what x itself is, we would have to subtract the 8. So x equals negative 3, or x equals negative 13. So there's our two solutions. If x is negative 3 plus 8 would be 5, and 5 squared would be 25. If x is negative 13 plus 8 would be negative 5, and negative 5 squared is also 25. And how about this one? X minus 5 squared equals 37. So x minus 5 would equal plus or minus the square root of 37. And since 37 is not a perfect square, if we want an exact answer, we just have to leave it like that. And then to finish solving for x, add plus 5 to both sides, and we can say x is 5 plus or minus the square root of 37. So that means we got two possibilities for x. One of those numbers is 5 plus the square root of 7, or 37, and the other is 5 minus the square root of 37. Decimal approximations, with the help of a calculator, approximately 11.08 and negative 1.08. But if we want an exact answer, we can just leave it like this: 5 plus or minus the square root of 37. Now we're going to talk about that completing the square method. So to understand how that works, you have to remember what happens when you have a binomial, that is something either plus or minus something else, and you square it out. You get the first thing squared, and then either plus or minus 2 times the first thing times the second thing, plus the second thing squared. Look at it the other way around. It's a factoring formula. How do you factor these perfect square trinomials into the first thing and then either plus or minus the second thing squared? So for example, if we started with x minus 5 squared as one side of the equation, we could multiply that out and it would be x squared minus 10x plus 25. Starts with x squared, ends with 5 squared, has 5 times x times 2 in the middle. And then from here, we could either subtract 25 from both sides and write it as x squared minus 10x equals 12. Or we could subtract that 12 and get x squared minus 10x minus 12 equals 0. Now let's look at this from the opposite direction. What if we started with this? X squared minus 10x minus 12 equals 0. And that's a quadratic equation that we are trying to solve. And you might think to try solving it by factoring, but it turns out that can't be factored. But we could sort of reverse our steps here. Starting from x squared minus 10x minus 12 equals 0, we could add 12 to both sides to get x squared minus 10x equals 12. We could add 25 to both sides of that to get x squared minus 10x plus 25 equals 37. And the reason we might want to do that, add 25, is because that makes this a perfect square. This is something just squared. Specifically, it's x minus 5 squared. And that's equal to 37. And now we can go ahead and solve that for x by taking square roots. So completing the square is basically the process of getting from something like this down to something like this. To turning what we have here into something that involves a square, a perfect square of something, so that we can then go ahead and solve for x by the square root method. So here's an example of that. X squared plus 12x minus 31 equals 0. If we're going to use this completing the square approach, the way we do it is we leave these first two terms, the x squared term and the x term, together on one side of the equal sign, and then we get the constant term over on the other side. So here I would start by adding plus 31 to both sides. X squared plus 12x, and I left a little space here, equals 31. Now think about what has to go in the space to make this a perfect square trinomial. Here's the trick. Look at the coefficient in front of the x, take half of that and square it. That's the magic number that you need to add onto both sides. So here when I look at that number, it's a 12. Take half of that, you get 6. Square that, you get 36. So add 36 to both sides, and then x squared plus 12x plus 36 is x plus 6, the quantity squared. Meanwhile, 31 plus 36 is 67. So now we're down to where we have something squared equals some number. So from here, we take square roots. Remember what happens when you have something squared equals a number? The something, in this case the x plus 6, equals plus or minus, the positive or the negative, square root of that number. So x plus 6 equals plus or minus the square root of 67, and then x equals negative 6 plus or minus the square root of 67. I subtracted 6 on both sides, and I could have written it as plus or minus the square root of 67 minus 6. Means the same thing, but I like writing it this way. The decimal approximations, if you put that in a calculator, when you do the plus, you get approximately 2.19. When you do the minus, you get approximately negative 14.19. So those are the two solutions. The exact solutions are negative 6 plus the square root of 67 and negative 6 minus the square root of 67. Now this completing the square method, notice it sometimes works when factoring doesn't. This is an example of an equation that we couldn't solve by factoring because we can't factor this. But we could solve it pretty easily by completing the square. Completing the square will always work, but sometimes it gets complicated and messy. But it works out really nice when you have an equation like this one where there's no coefficient in front of the x squared and where the coefficient in front of the x is an even number. Because then when you take half of that, you get a nice whole number, square it, you're good to go. So I like using completing the square to solve an equation like that. There's nothing in front of the x squared, and the number in front of the x is an even number. If that's not true, like if we had something else in front of the x squared, then it gets a little more complicated. And I'll talk a little about that in another video. But before we leave this, let me show you the sort of visual or geometric interpretation of what's going on. You can think of this as literally completing an actual square that you can look at. In fact, that's the way that ancient mathematicians kind of thought of this. So we can think, okay, we're solving the equation x squared plus 12x equals 31. You can picture that as x squared would be like a square that's x by x. And 12x would be a rectangle that's 12 by x. And adding those together is you're adding together the area of the square plus the area of the rectangle, and that's equal to 31 square units. The way I've drawn it, it looks like 12 is longer than x. I don't know for sure if that's true. I don't necessarily know if I've drawn things to scale. But if we take this rectangle here and cut it in half, instead of just 12 times x, it's 6 times x plus another 6 times x. A 6 by x rectangle plus another one. And then I move one of those over around to the other side of this x by x square. So it's still the same amount of area, just rearranged in a different formation. So now we got x squared plus 6x plus another 6x, and the whole thing is still equal to 31. Now what do I have to add in here to complete this square? The missing hole here is a square of size 6 by 6. So I added in a 6 by 6 square, which had area 36. And yeah, this really isn't to scale because the orange part is 31 and the purple part is 36, which should look bigger. But you get the idea of the shapes anyway. So when we added the 36, that was like taking our original equation x squared plus 12x equals 31 and saying, okay, x squared plus 12x plus 36 equals 31 plus 36. So when we added the 36 to both sides of our equation, we were completing this square and saying, okay, x plus 6 squared equals 67.